I want us to look at is, do we see the top fraction up there? X plus y over b. And then the bottom fraction is x plus y over b squared, correct? So the very first thing we want to do is we want to look at the denominators of our two smaller fractions. So we're looking at b and we're looking at b squared. And the reason we want to do that is because what we want to do is we want to come up with a common denominator between the two. So if, just like when we were adding and subtracting, if my denominators were b and b squared, what would my common denominator be? B squared, okay? Everybody agree with that? Once we decide what our common denominator is, what we're going to do is we're going to multiply the top fraction by that common denominator, and we're also going to multiply the bottom fraction by that common denominator. And this is what I mean. We're going to take this top fraction, and we're going to multiply it by b squared. So I'm going to show my work right here, and then I'll erase it. But if I have b squared times x plus y over b, what does that make that denominator b do? Right, think about this. It's b squared times x plus y over b. What can I do with those b's? I can make this one disappear and change this squared to a 1. So that leaves me with just b times x plus y at the top. Does that make a little bit of sense? Okay, so what I'm going to do is I'm going to write that b times x plus y. So now I've gotten rid of that first top fraction. Then I need to do the same thing to the denominator of the bottom part of this big complex fraction. And I want to multiply that by b squared. I'm just going to come over here and do that. Showing my work. What are those b squareds going to do? Cancel. And so that's just going to leave me with what? X plus y. So that goes on the bottom now. So by coming up with a common denominator for my two smaller fractions, multiplying the top of the fraction by that value and the bottom of the complex fraction by that value, what happens is it gets rid of the two smaller fractions, leaving me with just a regular fraction. Then I want to see, can I factor anything? Do I have any like terms, or is there anything that can be factored? No. Okay, it's already kind of factored for me, right? Is there anything that I can simplify? What? I can get rid of those x plus y's, and that would leave me with just what? B. So a lot of what we did yesterday and the day before about getting our common denominators and using those is going to be the same, but that kind of changes after that. Okay. We have to look at our smaller fractions first, figure out what our common denominator is. Multiply the top part of my complex fraction by that to get rid of every fraction. Multiply the bottom part, that gets rid of every fraction. And then we can work from there. Is that kind of okay? All right, looking at number 2. Look at your smaller fractions. I want to focus on the denominators only. If that one would stay. If my denominators are a and a squared, what would my common denominator be? A squared. So what I'm going to do is I'm going to multiply actually the top and the bottom of this by a squared. I'm going to come over here and do the top part first and show my work. A squared times 1 plus 1 over a. What do you think we need to do with that a squared? Distribute. What's a squared times 1? Okay. And then if I do a squared times 1 over a, if I can get my pen to write. Trying to write it over here. What do I end up with there? A, right? Because that gives me a squared over a, which is just a. So that's going to be what's in the back. That's the top part. I'm going to stop because I see some confused looks. which, do we understand where the a squared came from? Do we understand where the plus a came from? If you multiply a squared times 1 over a, then that gives you a squared over a, which is just reduces to be a. Let's do the same thing at the bottom. We're going to take that a squared, and we're going to multiply it by 1 minus 1 over a squared. A squared times 1 is just a squared. What do I get if I multiply a squared times 1 over a squared? A squared over a squared, which is just 1, right? That's what we have on the bottom. Okay, what I want you to do next is factor the top and the bottom if they can factor. We've changed our fraction. We can always change a fraction by multiplying the top and the bottom of it by the same thing. We happen to multiply it by a squared this time. That resulted in a squared plus a over a squared minus 1. Before we can start simplifying, we need to try to factor the top and the bottom if we can. Does a squared plus a factor? Yeah, what can I pull out? An a. And that's going to leave me with a plus 1. What about that denominator? A squared minus 1, does that factor? Yeah, they're both perfect squares, so we can break it up into 2. Square root of a squared is a. Square root of 1 is 1. 1 plus, 1 minus. What can I get rid of? A plus 1. So what's left at the top? A, and at the bottom, a minus 1. And you can't simplify those a's because that bottom one is attached to that 1. Okay. Get a common denominator. Multiply the top and the bottom of our complex fraction by that common denominator. That should get rid of my smaller fractions, leaving me with just one regular fraction. Factor the top and the bottom if you can. Simplify if you can. Are we kind of okay there? Sort of? I want you to try number 3. Okay, we'll do 4 together, but I want you to try number 3. Look at your smaller fraction. Come up with your common denominator. To turn this into a fraction. Oh, you're talking about pressure. This is a squared. So a squared means a times that make sense? Come up with your common denominator. You look at your 2 smaller denominators, 2 small fractions, the one at the top and the one at the bottom. Come up with your common denominator. Once you figure out what that is, then you want to multiply the top and bottom of that complex fraction by that common denominator. if my two small denominators are x squared and x, what would that common denominator be? X squared. I just want to get you started here. Okay, so we're going to multiply that whole thing by x squared. I'm just coming over here to the side so I can show you guys my work. If I distribute that, that's going to give me 9x squared minus, if I multiply x squared times 1 over x squared, what does that give me? Just 1, right? So at the top, I'm left with 9x squared minus 1. Then we're going to do exactly the same thing to the bottom. We're going to multiply it by x squared. I'm going to come over here and do that. We want to distribute. 3 times x squared is 3x squared. What is x squared times 1 over x? Just x. Okay. Now keep going. Factor the top, factor the bottom. Nine x squared minus 1. Those are both what? Perfect squares. So I can factor that. The square root of 9x squared is 3x. The square root of 1 is 1. We put 1 plus and we put 1 minus. What about the denominator? 3x squared minus x. What can I do there? Take out an x, yeah. And if I take out that x, what's left? 3x minus 1. Do we see anything we can get rid of now? 3x minus 1. So at the top, we are left with 3x plus 1. At the bottom, we are just left with x. Can that simplify it all? No. A little bit more sense, kind of. Okay. All right, let's take a look at 4. So because these are a little bit harder and longer, you only have like 4 questions for your homework. So. I have 1 over a minus 1 over b, and all of that is 1 over a, has 1 over a plus 1 over b at the bottom. So look at your denominators. What are your small denominators? A and B, right? A and B, A and B. So what do you think our common denominator would be? AB. Just A times B. If your denominators are completely different, they don't have anything in common, then you just multiply the two to get your common denominator. So we're going to start by multiplying the top and the bottom of this complex fraction by A over B. I'm sorry, by AB. Do that one first. Do AB times 1 over A minus 1 over B. What's the result if I do it by AB? What do I get when I multiply AB times 1 over A? AB over A, which would just reduce to B. B, because the A's will cancel. And then if I multiply AB times 1 over B, what does that reduce to be? Just A. Okay, so at the top, I'm going to have B minus A.
Then I'm going to do the same thing for the bottom, AB times 1 over A plus 1 over B. So go ahead and do that for me if you haven't already. What's the result there? AB times 1 over A is just B, and AB times 1 over B is A. So at the bottom, I end up with B plus A. Can those factor at all? Can I simplify those? That's all we can do there. Everybody kind of okay? All right, now I need to look through what I have left and see. I want to make sure, because the first two of your homework questions are going to be like 1, 2, and 3, very similar to those. The next two of your homework, I need to make sure we do an example like those. So let me just skip through. Here, we're going to skip 5. We'll do 6, just for time's sake. And I want to make sure you have an example very similar to what those questions in your homework will be. I promise on the test I will keep this part as simple as I can while still testing that you can deal with complex fraction. I got 1 plus 2 over y plus 1. All of that is over 1 plus 4 over y minus 1. So let's start by looking at our denominators of our two small fractions. I have y plus 1 and I have y minus 1. Are those the same? No. So for my common denominator, I should just do what with them? Multiply, which means I'm just going to put them in parentheses and leave them like that. Just like when we had our two different denominators, A and B, they were completely different. We just multiplied them to get our common denominator. The same thing here, except for I have binomials. So we're going to start by multiplying the top by that. If I can write. I'm using these big brackets just to kind of help me differentiate what I'm doing. I'm going to kind of go slow so everybody has a chance to write and look at the same time. Okay, so my common denominator, y plus 1 and y minus 1, is being multiplied by that entire numerator of this complex fraction. So let's start here. If I multiply those by 1, what am I left with? Y plus 1 and y minus 1, right? Nothing cancels there. I'm going to bring down my plus sign. And if I multiply this second part by those two, which part of it is going to actually cancel? Y plus 1s. So I'm going to have that 2 times a y minus 1 left. Let me show you that up here. So if I have y plus 1 times y minus 1, and I am multiplying that by 2 over y plus 1, think about this. Those are one at the top, one at the bottom, so we can cancel those. And we have that part left, right? Is everybody okay so far? All right. Now, I have y plus 1 times y minus 1, but then I have plus 2 times y minus 1. What do you think I need to do first? I need to distribute. I need to multiply everything that needs to be multiplied so that I can then add those two parts together. What's the matter? Did I lose you? No. Okay. All right, let's do this. Start here. Multiply these two. Distribute everything out. And do all of that. At this point, we should probably know what that is being multiplied as much as we've done difference of squares, right? Y squared minus y plus y minus 1, which gives me what if I combine all that together? Y squared minus 1. Okay. All right, then I need to do the second part. I need to distribute that 2 to the y and to the 1. Whoops. What do you think you should do next? Combine your like terms first? I was just looking. What can I combine? If I start with my y squared, are there any other y squareds to combine? No. Then I want my y terms next. I only have one of those, so that would be plus 2y. And what does -1 and -2 give me? -3. Okay. So after all of that work, that's the result of my numerator, correct? Got to do the same thing for the denominator now. That's why you only have 4 questions for homework, because a couple of these take a while. Is everybody okay if I erase that work that I just showed? Because the y plus 1's canceled out. So, is everybody okay if I erase that work? Let's do the same thing at the denominator. Again, it's going to take a little bit of work. We are going to multiply all of this by that. I'm just going to write it over here, though. My common denominator is being multiplied by the bottom part of my complex fraction. So start the same process, just like we did with the top half. Some people ask me why I don't go ahead and multiply the y squared or the y plus 1 and the y minus 1 together before I multiply the top and the bottom. That's because I can't see what cancels if I do that. So if I leave it factored, then I'm able to see what I can get rid of, if that makes any sense. All right, so again, we're going to do the same thing. We're going to take these two and we're going to multiply them by 1, which just gives me y plus 1 and y minus 1. And then we're going to do the same thing for the second part. Y plus 1 times y minus 1 is going to be multiplied by 4 over y minus 1. What can cancel there? Y minus 1. So for that second part, I would just have 4 times y plus 1. Now do all of your multiplying, just like we did with the top part. What is the result of multiplying y plus 1 and y minus 1 after I combine my terms? Y squared minus 1, okay. Then I'm going to distribute that 4y, or that 4, to the y and the 1. Then I want to combine my like terms. What's that going to be? Y squared plus 4y, what? Plus 3. You think more like a regular question on the test or a bonus question? All right. What do I need to do to finish now? Factor the top of our fraction and the bottom of our fraction. Let's see if anything can cancel so that we can simplify. You know, all of that work was just multiplying the bottom. And I promise you, this is the easier way of the two methods that you can do this. You wouldn't want to see the other way? At the top of our new fraction, I want numbers that multiply to give me 3 and subtract to give me 2. What are they? 3 and 1. Different signs, bigger number, so plus 3 minus 1. What about the bottom? Numbers that multiply to give me 3 and add to give me 4 are 3 and 1. What are my signs both going to be here? Positive. And so what can I get rid of? So at the top, I'm left with y minus 1. At the bottom, I'm left with y plus 1. Can those cancel?